Okay, so this is the RoboJackets mechanical training. This week, we're going to do a very basic level of CAD introduction. But before we do, let's meet some of your trainers for this time. So I'm going to try to skip through these. These people aren't important, but if you go to the Tuesday session, you'll see them. All right, Sean, you're first up.
Hello, I am Sean. I'm a master's student and I'm in RoboCup. Oh dear, my camera. That's pretty good. Okay, that's better. So yeah, I'm interested in control systems, which is why I joined RoboCup. And yep, I love cooking, video games. This is something I made yesterday. That half an hour ago reversed to yesterday, technically.
Looks great.
Yeah. Cool.
All right, who's next? Is it me or Keaton? It's me, okay. My name's Kyle Heiss. I'm a fourth-year mechanical engineering major with concentration in robotics and automation. I'm on the Robo Wrestling Mech team, so Robo Wrestling is RoboJack's newest team. I'm also a facilitator in Grand Challenges, and I was part of the Grand Challenges 2017 group. So if you're in Grand Challenges, let me know. Some of my hobbies are I really like video games, like a lot, like all kinds. I love rock climbing, cooking, volleyball, but I'm not super good, though I enjoy it quite a bit. Reading, D&D, and traveling, as you see. So these are some of the pictures from the bottom left ones from the Mediterranean, top left one's Swiss Alps, and top right one is with someone else from RoboJackets, actually, and that's in Cambodia. Yeah. You're up, Keaton.
Hey guys, I'm Keaton. I'm a third-year computer engineering major. I'm a mentor with the 3-pound BattleBots, as well as a member on the hockey BattleBot, specifically controls. I'm all about League of Legends, D&D, Marvel, and malware. So if any of those pique your interest, hit me up and I'll talk forever about those. And then a couple things on the side there. I don't know if you guys play League or not, but I'm a brand main. And yeah, that's me.
I love this. We're going to have to talk about the Bards as the best class, though. I'm not sure if I agree with that one.
For charisma casters every time.
All right, so let's get started. So today we are going to be covering a very base level of CAD, as I said. So CAD stands for Computer Aided Design, and most of you will be using it throughout your ME career or whenever you want to design something, whether it be in a club or just a personal project. In RoboJackets, we use Inventor, which is a CAD software from Autodesk. But for jobs, classes, and other clubs, you might use programs like SolidWorks, which is used in ME 1770, or Creo or Fusion, or a lot of different other CAD softwares. They all follow the same basic idea, so these skills are pretty transferable, though some get pretty wild, but I hope we don't use a lot of them here.
I was in the electrical area, Freddie.
So one benefit of CAD is that you can really iterate designs very cheaply because it's on a computer and not directly in front of you. And the software has become powerful enough to get a pretty good prediction of the final product. So it doesn't always replace real visualizations. And so some people come into GT and they take ME 1770s and they're like, oh, why do we have to do hand sketches? I will never use this because like CAD exists, right? And I can say that's not always true. Hand sketches will always be the cheapest because all you need is your mind and your engineering skill. And hand sketching is also super useful because a lot of small companies might not be able to afford a license to CAD software. Or you're sitting with another engineer, you're brainstorming, you just need to like sketch something out really quick. Being able to hand draw sketches is a really useful talent. So that's why we focus on it in the beginning of the ME curriculum. So let's talk about some CAD terminology. These things are organized of the order for typical design. So you usually go from a sketch to a feature to a part and then to an assembly. But what do these mean? So a sketch refers to the lowest level of the design. Usually it's a 2D element that can be used to define features later on. Features are 3D aspects of a part. So these are elements like holes or cutouts, and they help define the function of a part. a part is a collection of features and sketches that represent like a real thing. So a part is pretty self-explanatory. It's like a spring in my pen or a screw in my headphones. And an assembly is a bunch of parts stuck together by defining characteristics, usually by faces or edges. So that would be the entirety of the pen or the entirety of the headset, right? So let's move on. So for the CAD space, so the workspaces in most CAD software are 3D, so they're XYZ coordinate plane like in geometry. Yeah, and all designs in the world make use of these small, simple geometric shapes like circles and squares. So if you think about the defining characteristics of like a wheel axle, it would be circles, right? And then plates are defined by a bunch of rectangles. And so you can start to build these complex designs with simple geometries that are either built up into something more complex or taking a complex geometry and breaking it down to a series of simpler ones. So right here is an example of the screen you would see when you start a sketch in Inventor, our CAD software. You'll see this weird looking 3D element in the center. So this is a bunch of planes intersecting each other at the origin. And in some CADware software, they're referred to as like top, right, and front. I think in Inventor, they're defined by the coordinates that are like tangent to them. So this would be like the XY plane. So sketches are 2D elements, so they need to be put on planes like these. They need to be defined by planes like these. And it's usually a good idea when you start a sketch or start a part to use one of these as your first sketch planes. So you just click sketch in the upper left-hand corner, and then you click on one of the planes to help define it. So computers are really, really smart idiots, right? They tell you they will do exactly what you tell them and not much more. This is especially true for CAD, and the way you help the computer figure out what is going on is called constraining. And so constraining is the act of defining some measurement or relationship in the CAD. And the examples would be like this line is 3 inches long. You tell it that these lines are parallel. This angle is 10 degrees. If you don't do these, if you don't help the computer understand what you're trying to design, it can really mess you up later down the line. And so this is a quick GIF of the beginning of a sketch and drawing a quick rectangle. You can see, so they click the sketch option in the upper left hand, and then they click on one of the planes that comes up, right? So they click on the top plane, or I think it's the XZ plane here. They grab the rectangle from the top left and they define it at the origin and then drag it out to an arbitrary point. So you might have noticed that the colors of the rectangle were different on some of the sides. This is Inventor's way of telling you that of what it knows and what it's guessing right now. So in this example, it is blue is known and green is unknown or free. And this changes in CAD software and versions, but they all follow this idea. They are trying to tell you like, okay, I know that like this corner is attached to the origin, but I have no idea where this free side is moving. So it could be anywhere right now on your design. There are a couple ways of constraining these things so that you can tell the inventor what they are, right? So these will be covered in other sections, but the important thing that we want to say right now is that it's important what constraints you use. You want to make sure the way that you defined your part is in line with how you will use it. So we'll go over some of these later, but like this is coincident, so 2 points come together. This is collinear, so 2 lines on top of each other. These just all help define parts of the sketch so that you can better understand how it works later. A common trick that a lot of people use in CAD is how will a part change if I move one thing, and if it does change in a way that you don't want it to, how do I add a constraint there to fix it? I will also say that a trick I pretty often use is if I have a sketch that's undefined and I don't know what needs to be defined, I'll just grab a part and move it and it will break. But Control Z exists for a reason, right? And so we just Control Z and figure out what's going on. So how do we fix it? How do we get rid of these green unconstrained free lines? One way to do it is for this example is to define a green element in terms of another known element, like an axis, a plane, or another blue position. So it's pretty hard to see here, but they show that they define it to one of the axes that we know. So we know the bottom left corner of the rectangle is on the origin, and we have this line that follows that. So we know that is on this plane. And so we say, oh, the height distance from the bottom line to the top line is 3 inches, and it becomes blue because now it knows where that height is. We still don't know what this one on the right side is, so this dimension is still free, so it could slide, right? A good flow that you want to follow is you want to sketch, then you want to constrain the element in different ways like parallel or perpendicular, anything like that, coincident, and then you want to dimension it. So this will help avoid this is the best practice to avoid errors in the future. So pretty often you'll find in RoboJackets, you're doing something, you're in your flow, you're trying to figure out what's going on, and something breaks and you don't know why. And that is a common occurrence that has happened to all of us. If there is something going on with your CAD and it's not constrained and you don't know what it is, you can always use show degrees of freedom by right-clicking on the sketch, and it will show you the ways that the sketch can move in red arrows. So all I would have to do for this one is I would right-click on the sketch. I would say, where can it move? And for the original, I'll go back. For this, if I were to right-click on this sketch and be like, show me degrees of freedom, it would say, oh, you can slide in this direction right now because you haven't told me how wide you want your rectangle to be. So just keep that in mind. That's a really useful tool. Fun fact, I didn't know about it until we went over training for this, so that's fun. So I'm going to be using that now. Okay, so we talked about sketches. The next thing that we do is we use the sketches to define features. So features are 3D elements of a part made by manipulating a sketch. And some common features are extruding. Extruding is the one that you'll probably use most. It's very, very common. Imagine dragging the piece of paper with the sketch on it in one direction to make a 3D shape. Another way to look at it is, did any of you all have those Play-Doh toys that you would like stuff a bunch of stuff into, and then you would squeeze it and it would come out as like a long like star or like a moon or something? That's very similar to what an extrude does, where you just take the profile and you stretch it. Another one is revolve. So this is really similar, except when you take the sketch, you rotate it around an axis instead of just bringing it up. So it makes like a circular shape, right? I don't think I have a fun Play-Doh one for this, but maybe come back and I'll think of one. Sweep. So I don't want to spend too much time on this. It's pretty uncommon. It's when you drag a profile along a curve. So that's good to make something like, they say a paperclip here. Yeah, that's a pretty good example. You take that circular profile and you drag it along the curve that would define like the bends in the paperclip. Yeah. So now that we've done features, let's look at, let's actually see the examples first. So this is what extruding is in a GIF. So you take that profile and you stretch it up, right? Like you're moving it up or you're pushing Play-Doh through it. So that's extruding. This is the most common one you'll use. This is revolving, right? So they select the profile they want to revolve. They then hesitate and select the axis they want to revolve around. And then there it is. It rotates it around the axis to form a circle. I doubt they show sweep here. Oh, they do so whole though. Nice. So the hole tool defines a diameter of the hole you want and the depth. So they have the base defined, and they just click on the center of the circle. That is already a point that was defined by the axis, right? So there's a little point here. They click on it, and now they have a hole there, defined by the axis. So it goes down into the part. So creating a rectangular person with previous sketch we get. Yeah, okay. So this is back to the sketch. So the building block of features are the sketches, right? The first thing that you focus on is the sketch. You have it define the features. So they have a fully defined rectangle here. They extrude it up into the square or the rectangular prism. And now they have a base for more features, more sketches, things to move off of. So parts. These are just a collection of features. They will end in a IPT file, which stands for Inventor Part File. And now you might ask, oh, Kyle, where does the T come from? it's probably from the T in part, but that does keep me up at night when I was like Inventor part file with an F. Yeah, I don't know. If there's so there's an example model tree on the right side here. So this helps you keep track of your designs in CAD, and they're organized in like a folder format, which we'll get into a little bit later. But basically, the largest thing that holds it is a part, and then under that in the folder would be like an extrusion or a feature, right? So this could be an extrusion, a hole, a revolve, anything like that. And then under that feature is the defining feature, the defining characteristic of that, which would be the sketch, right? So the sketch defines the extrusion or the feature, and the features define the parts. So you can go up like that as well. So this is where it all comes together, and you get to see something like the bot we see on the right, which looks like an undercutter from BattleBots. Keaton can correct me on that if he knows the name of the bot.
It's a Valkyrie, right?
It's Valkyrie. Okay, there you go. So if you're on BattleBots, that is one of the bots from this past year. So we take all our part files and we constrain them together, and there are a lot of ways to do that, which we will cover in another session. Yeah, we'll cover in another session. Almost always the best method for constraining a part is based on its real interaction with other parts. But usually a good way to follow it is just imagine where the real world parts would touch and use that as your defining feature. If you look at this example over here, you see some shaded lines between different elements. Those are dividing features of parts. So this back plate would be a part, and it's separate from these side panels because you can see these separate lines, and they're separate from the front panel as well. So just an overview of some of the things we learned today. We'll be using a CAD software, a computer-aided design software called Inventor, Autodesk Inventor. And the best design flow that we want to do is we want to start with a sketch. We want to use that to define a feature. We want to start with the sketch. We want to constrain, and then we want to dimension it. So we want to use constraints to talk about its design and why we want it there. Then we want to dimension it to fully define it. Then we want to take the sketch and define a feature with it. We then can continue defining features and create a part, and then we take those parts that we've created and assemble them into a final product. So that's all for the intro lecture for material today. We will be doing a CAD guide walkthrough after this. One of the things that we want you to do is an intro survey. So we would like to get an idea of who you are, what team you want to join, and your experience with some of the tools we commonly use. Don't worry if this is all new to you, and that was a lot. I knew absolutely nothing when I came into RJ, and well, okay, I still don't know very much, but I know definitely more than I did. And we're here to help you through it all, so no worries. Let me drop this in the chat if I can get to it.
I got you.
You got me? Awesome, thank you. So please take a moment to fill that out when you get a chance. I'm going to be moving over to the CAD example right now, and then we're going to be doing a walk through that. If you don't have CAD, don't worry. I'm going to show you how to log into a remote system so we can access it. Okay. No, that's not what I wanted. I want to present Lamau. Okay. So this first week, we're going to do a really simple design, and we're going to do it two different ways to talk about how do you CAD for best design practices, or even for like time saving, let's say. So there's two main ways to access Inventor, the CAD software you use. One is locally on your machine, and two is through the VLab, which is what I'm going to be showing because it's what I'm going to use today. So using the VLab, I'm just going to actually show. So the first thing you're going to want to do is you're going to go to this link at the bottom. You're going to go to mycloud.gatech.edu. So it probably already has it for you. mycloud.gatech.edu is what you want to go to. You're just going to slam on in. You're going to go over to desktops. And you're going to go to College of Engineering 2020. That already has Inventor installed on the main screen. So all you have to do is boot up this remote machine and then access Inventor. So again, I went to mycloud.gatech.edu. then clicked on desktops, then I'm going to go to College of Engineering or COE 2020. And click on it and hit open. And you might have to download, if you haven't used a remote desktop before, a Critics receiver. I'm just going to say open because I already have it on mine. This doesn't matter, it lies to you. And I'm going to wait for a second with bated breath. And here you can see it's trying to open. There you go. And you see I already have the part made. We're done. That's it. No. But if you go to this here, I'll close Inventor so I can show opening it up. If it will let me. Please. I just want to close your program. There you go. So I'll say no, because we're going to do it together. And you should see this screen, or very similar to this screen with the gray background. Just double click on Autodesk Inventor and it should open up. So back to the CAD guide. And if you have any trouble with that, let me know, or post in the chat, and Sean and Keaton will help you out. So I showed this. You go to mycloud.gotech.edu. You click on COE 2020. You open it up, and we get ready to go. If you want to do a local installation on your computer, I don't do it because it's too much space for me. But if you have a fast computer and you want to just, always have access to Autodesk, just go to this link. If one of you guys can post in the chat, if you haven't already, please do. You go to that link, you create an account. It could be your personal email, it could be a gotech.edu, it could be whatever you want. We download the educational license per your system, and we'll be working on 2021 this year. It's a pretty beefy file, and Autodesk also installs a lot of material packages and other elements onto your computer. So definitely take several hours to install is an understatement, I think, on some of the dorms Wi-Fi. But yeah, if we are ready to go, I will jump in to the CAD example that we'll be doing today. Is there any questions before I jump in that I need to address, or can I go right into it? Okay, I'm going to take that as a let's go right into it. So how am I going to do this? I'm going to have my CAD up on this screen and the presentation over here. So if you have the presentation, please follow along. If you don't, can Sean or Keaton please drop it into the chat for me, please? So first thing I'm going to do is boot up Inventor.
I think Keaton already did.
Oh, what a G. Thank you.
No problem, dude.
A legend. Maybe bards are the best class.
Hey, coming around, I see.
So it's a little slow on the remote machine. When you guys open it up, you might have like a start learning or start working. If you want to go through the tutorial start learning, you definitely can. But if you just want to click on start learning and follow along with me, that also works. So there's 4 different options here. When you open up the main screen, there's part, assembly, drawing, and presentation, I believe. We're going to be focusing on part right now. So click on that. And if I'm going too fast, type in the chat and someone give me a shout out. So first thing I wanted to notice is the left on here, the model tree that we're talking about, or it's also called a feature tree sometimes. It has nothing in it right now besides the part. So there are no elements that define the part right now, but we still have one. We're going to start a sketch. So we're going to click on this left button up here, the plus next to the sketch, the start 2D sketch. And you're going to see it comes up with the same planes we were talking about before that intersect at the origin. Let's see what they're called. Okay, yeah, so Inventor defines them based on their axes that are tangent to them, right? So this is the XZ plane, so it is defined by the 2 axes at the bottom left. Let's click on that top one for right now. You see it takes you normal to it, so you're looking down as if you're like looking at a paper in a 2D environment. So we do that. We start on the XZ plane. We're gonna draw a circle. So here are the if you can't see this, click on sketch. There are a couple elements here. We're going to click on circle as our first one. We're going to be making a rivet. So it's going to be like a screw with a hole in the center, basically. We're going to click on the origin. So you see how I'm just floating around in space, but when I get close to the origin, it like clicks in and it's green. That's Inventor's auto assist, and it's telling you like, oh, this is where I want to place it. I want to place it at the center of the screen. So I'm going to click once it's green. You can see that it allows me to drag and define this dimension freely. So I'm going to make it real big. It is not dimensioned right now, right? So we see that it's blue. So we said the blue is the, well, actually, hold on. I'm going to dimension it. And we're going to set it as, let's see what it says us to, 3/8. So if you didn't follow what I did there, I clicked on dimension up here. Okay, so in this version of Inventor, blue is undefined and black is defined. So you saw right here, it's blue. That means this is free to move. I haven't set it to be a dimension, right? It knows where its origin is, but I don't know what its diameter is. So I'm going to go up here to where it says constrain, right? And I'm going to add another constraint in order to make it fully defined. I'm going to click on this, and I'm going to set a dimension. So we're going to set it as 3/8 inches. And Inventor is really dope. So if you don't know what 3/8 inches is in decimal, you can just be like, oh, 3/8 inches. And there you go. It's got it for us. The next thing we're going to do is we're going to define another circle inside. So we're making like this hollow tube that's at the center of a rivet. So we're going to grab another circle. We're going to, again, put it at the origin. And this time we're going to put it inside the axis of the circumference of the other one. Now, so remember, I said there were multiple ways to define a feature. You can either define it by its existence to axes, planes, or points, or you can define it by other already defined points. So for this one, I know the thickness of the rivet I want. I want it to be a 1/16 inch thick rivet. And so instead of defining it as a diameter, I'm going to take the dimension and I'm going to go inside. I'm going to click on the smaller one first and then click on the outer one. And now you see I've defined their distance to each other of the two outer profiles. So I'm going to go in here. I'm going to do the same thing. I don't need to know what this decimal is. And I'm going to define that distance. You can do the same thing by clicking on the outer one and then clicking the inner one, whatever you want to do. Yes. So that is going to define the inner tube of our rivet. Once I'm done with the sketch, I go up here and I click Finish Sketch. It's not going to let me extrude the profile until I finish the sketch. So I say, I'm good. This is what I want. Check it over. I'm done. Next thing we're going to do is we're going to make the that tube portion of the rivet. So I'm going to click Extrude. And the first thing Extrude's going to do is ask me to select a profile. So what I want to extrude, what I want to push out with Play-Doh, right? And so you see that I have an option to do the inside. I don't want that. I want to do the tube. So I'm going to hover over just the part that would make the tube. I'm going to click it. It's going to ask me for a distance. So there are a couple options here to go over. One of them is just the direction of most ease. So it's wherever you're looking. Like for right now, it would go up. If I want to flip that, it goes backwards, right? So this is positive direction in the positive y. This is negative y. This is both in the same in equal distance. These aren't really important right there, and these are different distances. You're going to want to click on this first one, the positive y, and your distance is going to be 1.8 inches. A big boy, a big tube. Next, we're going to make the top of the rivet, right? So what actually contacts the material. So again, I said there are different ways to define elements and sketches. They have to be defined by a plane. So every extrude or every feature also defines other planes that can exist. So what I'm going to do is I'm going to click on the sketch, but instead you see no longer those origin planes come up. Instead, I have to define it based on the, or instead I'm going to define it, you don't have to, but I'm going to define it by planes that already exist on the part. So I'm going to click on the positive y top of the part, like that. And now I can sketch directly on this element. So you see how it could start to build, how you could start to define more faces and get more complex parts. for this, we're going to use something called project geometry. So if something already exists that has like an outside profile or an inside profile, you can project that onto the plane, the sketch plane, instead of trying to sketch it again, right? So I can click on project geometry, and what am I going to do? Am I going to select the outer inner profile? The outside of the sketch's scope. Okay, so I'm going to click on project geometry, and I'm going to click on the outside. You see how it's highlighted green? That means you've selected it. So I'm going to click on the outer profile. You see how it becomes yellow? That yellow means that geometry has been projected onto the sketch that I'm currently doing. I'm going to click out, or I'm going to hit escape to get out of the project geometry thing. And I believe the next thing they want us to do is to draft another circle. So I'm going to go to the origin again. I'm going to wait till it clicks green. I'm going to pull out. And this one's going to be a 3/4 inch. So I'm going to draw the circle. I'm going to hit escape to get out of the circle drawing. I'm going to hit dimension. And I'm going to go to 0.75 inches. So now you see that there are a couple profiles we've made here. There's this inner profile on this sketch face of everything within this projected geometry. There's also the profile between these two. The profile between the two circles is what we're going to want. So we're going to exit the sketch. We're good. We've done it. We're killing it. We're going to click extrude, and extrude, first thing it's going to do is ask you what profile do you want to extrude? What Play-Doh do you want to push? You're going to click on the profile that I mentioned before, the one defined by the space between the two circles. Oh, that's not right. We're going to select the distance to be 1/16 of an inch. That's not what we want to do. If you ever accidentally hit like confirm, you can just go over to the model tree, right click, and then edit feature. If you want to edit the sketch, you can also do that, but just click edit feature. So this doesn't make any sense, right? Because I've extruded upwards, and the part right here at the corner would be like 0 thickness. So this doesn't make any sense to do. So what we want to do is we want to change the direction of the extrude. And I saw how to do that before. I flip to the -y direction. So I flip it, and now it makes sense. Now there's some overlap. This could actually be made. And so I'm going to click OK. And there you go. You have your first CAD part, a rivet. Yay. I'm happy that I did it. You know, I was really nervous, everybody, that I couldn't. I don't use CAD that much, so that I couldn't do this, but we killed it. We did it. So I'm going to show this. This is one way to do it. I'm going to show you another way to do it that might be interesting to some people, or not. Who knows? So I'm going to click all the extrudes. I'm going to delete them just to get back to our base part. Right? There's no features in here. There's no sketches. There's nothing that defines the part. And this time I'm going to use a revolve instead of a couple of extrudes. So I'm going to look at this. And I'm going to click, instead of the XZ plane that we used before, we're going to click on the XY plane. So remember what revolve is. We take the paper and we revolve it around the axis in the center. The axis in the center. And so the first thing that I'm going to do is we're going to make a construction line down the center, down this line here. So construction lines are used to help define characteristics or dimensions of a sketch. And usually they're used just to help the CAD. They don't have any impact on the actual features of the design, just to help the CADer. So I'm gonna click. Let me be more specific what I did there. To make a construction line, you can see there's formats over here. So the only thing that changes between a line and a construction line is that it's dashed. And so I'm going to click this button right here, the center line. And I'm going to drop one right here. And so that's going to be a construction line to help us figure this out. Next thing I'm going to do, if you rotate incorrectly, there's a viewport dialog over here that allows you to just flip back to any dimension that you want or any view that you want. You're going to take a line and you're just going to sort of draw like a square element. Oh, this is actually not how they want you to do it. That's all right. We'll do it free. So you're just going to draw a thing here. And you're going to do it in the rough shape. Oh, I forgot to turn off construction or center line. You're just going to draw it in the rough shape of that profile if I was to cut it in half twice, right? So let me show you what that means. I'm just going to take a rough profile of the rivet. So this is what it would look like if I were to cut it in half, right? And I didn't have this left side. If your lines come up wonky, you can always make them parallel or perpendicular using these two features up here. So parallel is this constraint. You can always hover over something and it will give you a little dialog box of what to do. And then perpendicular is this constraint. And so I can make two lines with a right angle, right? And then all we have to do is define some features. So I want to say from the center line, from the center of the part to the outside of the part. And look what Inventor does here. So it lets us know that this is the whole dimension of the part. So let's look at how big that would be. So how big was that for the other time? It was 0.75 inches or 3/4 inches. Oh, it got big. What are some other features that we remember? So we know that the distance from the center of the part to the outside of the part, or the total distance of the outside of the rivet, was 3/8. And we're in inches, so you actually don't have to type in inches here. We also know that the dimension from the outside of the rivet to the inside of the rivet face was, if it will let me do it, was 1/16. The last thing we know is that this dimension here, the distance between the two pieces at the top, was also 1/16. And then it looks like I need to define the center line. Yep. So let's show what I did before. So I click on this and I say display degrees of freedom because I don't know what's wrong with the sketch right now. It has dimensional freedom in every direction. So that means I'm not constrained to like an origin element. And so I'm going to take this collinear constraint. So that puts two lines on top of each other. I'm going to click our center line and I'm going to drop down the origin over here because I want to define it to this up and down line here. I'm going to hover over this. Oh, no, you see that's this dimension. So the x-axis isn't right. The y-axis is what I want it constrained to. So I pop it in and you see that it all becomes, oh, its height is wrong too. Okay, well, we'll do that too. We'll do that again. We'll say collinear, grab this, and this time we want, let's hover over them. It's not the z, because we can't see that, right? It's not the y, it's the x we want it constrained to. And then we want its height, its total height, to be 1.8, which is what we had before, right? Hopefully that's what we had before. Yeah, 1.8. Then what we're going to do, now that we have our sketch, we're going to finish it. And we're going to revolve it. So we're going to go back to the 3D model. We're going to take revolve. And it just does it for us, right? So there's a bunch of different things you can change here. The angle of the revolve, everything like that. But we want it to go all the way around. And so with two actions and one feature, we've created the same part that we did before. I would say this was a harder way to do it. I would probably, if I was CADing, I would do the two extrudes. But it's whatever you think is the best way to do it and what helps you most later on. So maybe this rivet needs to have a lot of different elements change, which are defined by the sketch. That would help us if we did it this way. Yeah. All right. I'm going to stop sharing my screen. If you have any questions, please let me know. That was a little more complex than I wanted it to be, that last part. I think the way they have you do it in the slides is actually easier than that, if I had to guess. But yeah, thank you guys. Was everyone able to follow along?
I was able to follow along on the first way, but on the second way, I got like once you were like doing the constraint thing with the freedom of movement, I got lost or I got behind.
Yeah. So if you get a chance, look at the slides. I'm fairly certain I did it actually incorrectly based on what they want you to do. Let me take a peek really quick. Yeah, so they have you define a box for the rivet, and then they do a sketch internally to that. This is also a fine way to do it. I'm going to be honest, I do not remember how to do construction lines. Keaton or Sean, do you remember how to do this? That aren't center lines?
Oh, shit. Sorry, I was not paying attention. I was in a different chat.
You're okay, no worries.
Yeah, sorry, what was the question?
Do you remember how to do construction lines that aren't center lines?
Oh,
If you right click on the line, you should be able to choose one of the the sundial options to turn it into a construction line.
Oh hell yeah. Okay, Keaton to the rescue. So if I do a box here, or just I guess.
Ooh, hold on.
Construction. Okay, so up here is the construction line. So if I wanted to do it the way they were telling us to do it, they would have you click on this button, the construction button. So it's that angle face. You then take and just draw a rectangle, or let's use the rectangle tool actually. Let's be good catters, Kyle. Take the rectangle tool, start at the origin, and drag it up into the corner. And now you've made a construction box, and you can dimension this too to help you figure stuff out. So we want the dimension to be, let's see, what do we want it to be? 3.75, 0.375.
I don't think you're sharing your screen.
Oh, well, no. Thank you. There you go. Okay, so let's do it again then. Thank you for telling me that. So this is the construction line up here. So it's this little red angled thing. Then you can take a rectangle, and we're going to use this as a guide for the rest of our CAD. So we're going to go up, and we're going to make a rectangle that is 3/8, and 1.8 tall. So these are the outer dimensions of our rivet, right? One thing that they haven't done is I would need to define, I'm going to go to this collinear constraint. So this is where you got lost, right? So grab the collinear constraint, which is this, where it has like two lines, one of them red, one of them black with a little dot on it. And I'm going to grab the bottom of it, and I'm going to put it, I want to put it on this axis, right? And so I can't directly click on the axis. I have to go over to this origin thing. And you might see it where it's like this, right? So it's all closed up. We're going to open up origin, because that's where the axes, dots, and planes that define the origin are located. And we're just going to hover over which of the axes we want. So I see right immediately that it's the x-axis, and I'm going to click on that. And now we have this bounding box that defines our the CAD. We're going to do very similar to what we did last time. We're going to draw a line here, basically, or the profile of the rivet. And then we're going to revolve that around. I'm not going to do that again because it's pretty much the same thing. Just use the construction lines to help you from the outside bounds. Yeah, hopefully that helped. Did it? Well, let me know, and I'll try to explain more if I can.
Yeah, I think it helped.
Okay, awesome.
Thank you.
You're welcome. Yeah, I'll stop sharing my screen. Anything else? Was that too much? Was that too slow, too fast? What do you guys think?
A little fast, I think, because
A little fast, okay.
when you say something and then we try to do it, and then I
I'm already
blank out, and then you already moved on to the next step.
Okay, I will keep that in mind for going forward. Thank you for that. Appreciate it. Yeah, okay. So definitely help with, or knowledge of other CAD softwares are going to help you during these portions. There's still a lot to learn. So there's actually, if you are familiar with CAD, there is another series of slides which hold an advanced model, basically. So more part formations, more development. I think they have some. You do some exterior plane generation as well. If you would like to follow those, I'm not going to do that here because it's going to take too long. But if you would like to do those as well to give yourself a challenge so you can keep learning, I will drop, or if one of the guys could help me find it real quick. Hold on, give me a second. CAD guides, week 0 advanced. Yeah, it's the Empire State Building. That's right. So if you know a little bit about SolidWorks or any other CAD software and you want to challenge yourself, try that out. It shouldn't go too deep, but it should be enough to maybe keep you entertained.